The position of the Sun in the sky is a function of both time and the geographic coordinates of the observer on the surface of the Earth. As the Earth moves around the Sun during the course of the year, the Sun appears to move with respect to the fixed stars on the celestial sphere, along a path called the ecliptic. The Earth's rotation about its axis causes the fixed stars to move in the sky in a way that depends on the observer's geographic latitude. The time when a given fixed star crosses the observer's meridian depends on the geographic longitude. To find the Sun's position for a given observer at a given time, one may therefore proceed in 3 steps. Calculate the Sun's position in the ecliptic coordinate system. Convert to the equatorial coordinate system and convert to the horizontal coordinate system for the observer's local time and position. This calculation is useful in astronomy, navigation, surveying, meteorology, climatology, solar energy, and for designing sundials. Equation of time. In addition to the annual north-south oscillation of the Sun's apparent position, corresponding to the variation of its declination described above, there is also a smaller but more complex oscillation in the east-west direction. This is caused by the tilt of the Earth's axis, and also by changes in the speed of its orbital motion around the Sun produced by the elliptical shape of the orbit. The principal effects of this east-west oscillation are variations in the timing of events such as sunrise and sunset, and in the reading of a sundial compared with a clock showing local mean time. As the graph shows, a sundial can be up to about 16 minutes fast to slow compared with a clock. Since the Earth rotates at a mean speed of 1 degree every 4 minutes relative to the Sun, this 16-minute displacement corresponds to a shift eastward or westward of about 4 degrees in the apparent position of the Sun, compared with its mean position. A westward shift causes the sundial to be ahead of the clock. Since the main effect of this oscillation concerns time, it is called the equation of time, using the word equation in a somewhat archaic sense meaning direction. The oscillation is measured in units of time, minutes and seconds, corresponding to the amount that of sundial would be ahead of a clock. The equation of time can be positive or negative. See the main article for further information. Analemma. The analemma is a diagram that shows the annual variation of the Sun's position on the celestial sphere relative to its mean position, as seen from a fixed location on the Earth. It can be considered as an image of the Sun's apparent motion during a year. It can be photographed by superimposing pictures taken at the same time of day, a few days apart for a year. The analemma can also be considered as a graph of the Sun's declination, usually plotted vertically against the equation of time. Plotted horizontally. Usually, the scales are chosen so that equal distances on the diagram represent equal angles in both directions on the celestial sphere. Thus, 4 minutes of time in the equation of time are represented by the same distance as 1 degree in the declination. Since the Earth rotates at a mean speed of 1 degree every 4 minutes relative to the Sun, the analemma is drawn as it would be seen in the sky by an observer looking upward. If north is shown at the top, west is to the right. This is usually done even when the analemma is marked on a geographical globe on which the continents, etc., are shown with west to the left. Some analemmas are marked to show the position of the Sun on the graph on various dates, a few days apart, throughout the year. This enables the analemma to be used to make simple analog computations of quantities such as the times and azimuths of sunrise and sunset. Analemmas without date markings are used as decorations on such things as sundials. They have little practical usefulness. See the main article for more information.